4 lock on 4.5, clear needles.
Needles center, fly up.
Thermo 2.
Roger. 5.1 for fuel at 4 miles.
214 is on, climb path slightly left course, correcting 2 miles.
214.
214 is slightly below glide path, very slightly right of course, call the ball.
Got a ball? Yep. 214, time to get ball 5.0.
Good ball, catch 27 knots.
With increasing frequency, before an aircrew sees a scenario in flight, they'll probably have experienced the same scenario in a simulator first. The increase in modern weapons systems capabilities, complexity, and integration has escalated the amount of training required for aircrew to master a weapons system. This rise in sophistication has not only affected flight training, it has affected flight test.
Slowing down.
The cost of training aircrew and obtaining the necessary amount of flight test data was growing. An alternative method was needed to fulfill training requirements, obtain flight test data, and counter rising costs. Simulation is that alternative method. Simulation is a safe and proven alternative to non-flight essential testing. For programs in the developmental or conceptual phase, simulation can be used as an engineering tool to perform test and evaluation. And simulation is realistic enough to train aircrew in the procedures needed to master a weapons system.
Gonna release slowly and then look at recovery stuff. Yeah.
You're all right, Peg.
I'm trying, babe. Really wrap it up. It gets flat and really wrap it up. Recover 6826, recover.
The Manned Flight Simulator facility represents over 12 years of simulation experience. A staff of engineers and computer scientists have dedicated themselves to avionics, flight dynamics, and target modeling. These people are experienced in systems integration, mission computer hardware and software, 1553 data bus interfaces, and high-speed bus interfaces. They have designed computer-to-aircraft interfaces, multi-port memory, and data bus interfaces. The result of their work enables engineers to test scenarios and instructors to effectively train aircrew at a much lower cost. For example, 2 simultaneous simulation scenarios covering air-to-air, air-to-ground, combat, formation, and training have been demonstrated, with the potential for using 4 simultaneous players. The Manned Flight Simulator is a computer network coupled with aircraft crew stations to make up a full flight and avionics systems simulation facility, able to support all types of military aircraft. The Manned Flight Simulator includes high-fidelity system simulations for flight dynamics and avionics, a wide field of view visual system for man-in-the-loop evaluations, and a motion-based system to provide acceleration cues. The Manned Flight Simulator was designed with generic architecture so it could be adapted to accommodate many types of aircraft. All cockpits are interchangeable, so they can be inserted into any of the 5 simulation stations. In the 5 simulation stations, engineers are able to investigate accidents, familiarize pilots with tests to enhance safety, provide normal and emergency procedure training, observe, evaluate, and improve aircrew procedures and coordination, and expose aircrews to emergency situations which could not be risked in flight. Select test conditions representing envelope limits which must be validated in flight. Evaluate flight weapons systems and integrated systems performance against a realistic threat. Expose aircrews to a hostile mission environment which might not be readily replicated while airborne. Provide aircrews with a mission rehearsal prior to the actual mission. And practice weapons release and firing procedures for ordnance with a limited peacetime expenditure allocation. The generic architecture, which allows all of these scenarios, is modular to accommodate growth and integration of new simulation technology. Avionics modeling is one of the features which provides accuracy and realism in the Manned Flight Simulator facility. Avionics models duplicate the functions performed by the actual aircraft avionics. The avionics models accept information via the multi-port memory from other models and use the information to respond to requests from the mission computer. Avionics models exist for the FA-18, the AV-8B, the F-14D, the X-31, the T-45, and the V-22. Ship motion and wake turbulence can be added for further realism. A second feature which provides high-fidelity simulation is the air vehicle flight dynamics modeling. Air vehicle flight dynamics modeling uses a mathematical model to provide a realistic dynamic representation of a given aircraft's behavior. Manned flight is capable of either implementing an existing mathematical model or creating a new one to simulate the flight dynamics of any military aircraft. An invaluable tool in the operation of real-time simulations is the standard simulation software architecture developed at MFS. The Controls and Simulation Test Loop Environment, or CASL, allows any air vehicle flight dynamics model written in Fortran or Ada to operate in the real-time simulation environment. The result is high-fidelity, simulated testing scenarios. Examples of existing high-fidelity, real-time simulations include the F-14, the FA-18, the T-45, the X-31, and the V-22. An important part of the simulation-to-aircraft interface is the mission computer. In-house technical experts currently provide AYK-14 and MIL Standard 1750A mission computer support. The AYK-14 is a high-performance family of modules that provides a wide variety of standard airborne computer configurations and includes pluggable modules, enclosures, support equipment, and software. AYK-14 configurations used at manned flight are for the FA-18, the F-14D, the AV-8B, and the V-22. However, if the chassis and modules are provided, MFS can support any configuration. The exact configuration of the AYK-14 computer can be selected to meet the processing requirements of any military system. The Naval Air Test Center is a proponent of digital flight control systems. NATC is developing the capability for supporting software requirements of digital flight control systems. This capability will include flight control system flight test experience, system control law design and analysis, software testing and support, and a flight control system support facility. Another system capability producing highly realistic simulations throughout the flight envelope is the motion base. One of 4 simulation stations, the motion base is capable of 6 degrees of freedom movement and able to reproduce takeoffs, landings, hover, and transitions. An analog system and host computer drives the motion platform, providing pitch, roll, yaw, vertical, lateral, and longitudinal translation in any combination with 1 G-force. The motion base is equipped with the wide-angle infinity display visual system, which displays the computed scene from the CompuScene 4 visual image generator system. Another feature of the manned flight simulator facility is the dome station. The dome was developed in support of generic simulation requirements. This simulation station is a 40 feet inside diameter, light-tight spherical dome with a cockpit support structure for the physical mounting of the simulator cockpit. The dome is capable of accommodating single, twin, and tandem seat cockpit configurations. There is a total of 3 projectors for the forward field of view, the aft field of view, and the area of interest. In addition, 2 projectors provide independent target generation. When integrating with the CompuScene 4 system, the dome projection system produces a computer-generated, distortion-free color image for display of realistic scenarios on the interior screen of the dome. The display field of view is 360 degrees in the horizontal plane and 90 degrees to minus 55 degrees in the vertical plane. 2 fixed base laboratory stations accommodate all standard cockpits. The laboratory stations are equipped with the same simulation capabilities, except for motion and 360-degree visuals. The laboratory stations provide medium-resolution visuals on 3 flat screens with a field of view covering 150 degrees by 40 degrees. The high-fidelity flight dynamics modeling and avionics modeling, instructor and operator control, 1553 mission computer support, and man-in-the-loop interface are all supported by the laboratory stations. The Generic Instructor Operator Station, or IOS, is the central control and monitoring station. It is external to the cockpit and manages all resources, devices, simulation, and visuals for the simulation workstation. In this room, the instructor or operator monitors and controls the simulator, its safety systems, the cockpit communications, aircraft failure insertion and removal, target mode, air traffic control, advisory emulation, image generation system, cockpit display and instrumentation, and aircrew performance. Any aircraft cockpit can be modified or constructed in-house to meet NATC's specifications for insertion into any of the 4 simulation stations. The cockpits contain actual or fabricated aircraft controls, instruments, and displays. The F-14 cockpit, the FA-18, the V-22, and the multi-reconfigurable cockpit have all been developed in-house.